In this video, I will show you how to convert the given decimal number to binary. Decimal to binary conversion. I will open the editor. Before typing the program, I will explain what is the procedure to convert a given binary number to decimal. I will explain first. So decimal number system is regularly we are using decimal number system, and computers can understand the binary. So how the given input which is in decimal form is converted to binary. So that I am trying to explain now. If the given input number is 78, 78 is a decimal number. 8 is at unit place, 7 is at tens place. So 7 into 10 plus 8 into 1. 7 into 10, 70 plus 8 into 1, 8. 70 plus 8 generates 78. So in decimal number system, the base value is 10. In binary number system, the base value is 2. Why? Because in binary number system, only two digits are available, 0 and 1. So we have to choose 2. We need to divide the given input value with 2, and each time we need to observe the remainder. So now if I try to divide 78 by 2, the quotient is 39, because 2 into 39 generates 78, and the result is 0. The result is 0. Now the latest number is 39. Now again I start dividing. So 2 into 19, 38. Then the remainder is 1. Remainder is 1. Next, 2, again this 19 should be divided by again 2. 2 into 9, 18. Remainder is 1. 2 into 4, 8. 9 minus 8, remainder is 1. 2 into 2, 4. Result is, remainder is 0. Next, 2 ones are 2. Remainder is 0. This one is, if the available number is lesser than the divisor, then we stop the process. So when to stop the process? If the dividend is lesser than the divisor, dividend is lesser than the divisor, we stop the process. Now if you observe the arrow mark here, one arrow mark is highlighted in this picture. The we need to the output is in this direction. We need to consider from bottom to top. Now what is the output? 1001110 is the answer for the given decimal number. So 78 equivalent binary number is, we have to read like this, from bottom to top we need to write 1001110. One more example we will. There is one more example. Suppose if the given input number is 29, if the given input number is 29, so this is in decimal form. We need to convert into binary. Binary means we have to divide with 2, because in binary only two digits are there, 1 and 0. That's why we are start dividing with 2. So 2 into 14, 28. Remainder is 1. Remainder is 1. Now the latest divisor value is 14. 2 into 7, 14. Remainder is 0. Next, the latest divisor 7. So 2 into 3, 6. Remainder is 1. Next, 2 into 1, 2. 2 into 1, 2. Remainder is 1. Remainder is 1. Next one is 200. Remainder is 1. So this becomes the most significant bit. We have to read like this. We have to read like this. From bottom to top, we need to consider the bits. Then what is the order? 11101. 11101 is the equivalent binary for the given decimal number 29. On top of these numbers, we can assume that 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. If we add the corresponding head weights, then automatically we will get the given decimal number value, that is 29. So what we are trying to implement in our program, so we will collect the input from the user. Okay, we will maintain an array. Why? Because here each time it is generating some remainder values. All these remainder values we need to maintain in an array. So for that we are we are declaring an array of some specific size. Okay, each time I am trying to find out the remainder, I am trying to find out the latest divisor. See, initially the divisor is 29. Next step, the divisor is 14. Next step, the divisor becomes 7. Next step, the divisor becomes 3. That means half of the input number. 29 of value is 14. 14 of is 7. 7 of is 3. 3 of is 1. Like that. Similarly here also. 78 off value is 39. 39 off value is 19. 19 off is 9. 9 off is 4. 4 off is 2. 2 off is 1. Like that. The same thing, whatever I explained on the this document, the same thing we will convert into program point of view. First, we need to open a new source file, import the required packages. We need a standard package, that is standard input output header file. Then start main method, so main function. Now we need to think about how many variables are required. As I told you that we need a number, we need a binary number. We are trying to generate, our binary number is available in an array. So I am declaring that as B, an array with some size. So 10-digit size. This size you can vary. And I need some control variables to run my loop. So I'm taking, and I need to collect an input number from the user, that is n. I need to read an input number. So as of now, I am aware of that. I need an array to store my output, because each time it generates a reminder like 1 0 0 1 0, something like that. So I want to store those binary numbers into an array, and to run my, I want to repeat the same steps again and again. I want to divide the given input by 2 multiple times. That means I want to executing the, I need a requirement like I want to repeat the same steps again and again. So I need a loop. I want to run my loop based on the one loop control variable I. On what number, what is my input number, which is in the decimal form, that is n. So like that we have to analyze. So we will provide a message to the user, enter a number, enter a decimal number. Generally we are entering decimal number only, but here the target aims at decimal to binary. That's the reason I clearly mentioned it as decimal number. Collect the input from the user. As it is an integer number, collect the input. The integer variable name is n. So after collecting, we need to start a loop. So the loop starts from I is equals to 0. And here we need to give some condition. Just I leave some space for the condition. And each iteration we need to implement it. We need to increment it. Now, here we need to apply the, suppose if my input number is 78, so what we done, 78 divided by 2, and we check the remainder, we check the remainder, that remainder where we are going to store that remainder, the remainders are stored in the input array, I mean in the array b of I holds the, b of I holds the remainder. So on what variable you are applying, on input number n, divide it what, 2. So this result, whatever it results, that value is holded by this array. That value is holded by this array. See, initially it is 78. In the next iteration, the n becomes half of that number. So n becomes half of that number means n by 2. Half of that number. If you want, just you can watch the document. So 29 off value is 4 point something. So we will truncate the fractional part. Only we will consider the integer part, that is 14. Again, 14 off value is 7. 7 off value is actually 3.5, but that floating point, the decimal, the floating point version is, the fractional part is removed. Only integer part is considered. Similarly, 7 off value is 3.5. Only integer part we consider. 3 off value is 1.5. Only integer part we will consider. So like that we have to divide this one. So 29 should become 14 for the next iteration. 14 becomes 7 for the next iteration. 7 becomes 3 for the next iteration. That means indirectly we are trying to divide it by 2. Divided by 2. That is the reason here I applied n is equals to n division 2. But how many times this loop will run? How many times this loop will run? There is, if you observe here, n value, whenever n value is 0, we stop the process. That means up to n greater than 0, we are running this program. So that's the reason here I left this blank. Generally, previously, when you are deals with the loops, we are given like I less than or equals to n, something like that. But this first time for this program, we are testing whether the input number is greater than 0 or not. If it is greater than or equals to 0, then we will continue. Otherwise, we will stop the process. Now, after this, our B of I holds the input, target binary number in reverse order. Now, I want to convert into original order. That is like I will take one more control variable. J is equals to I minus 1. J is greater than or equals to 0 and J plus plus. So initially I did not declare that J. Now I will try to declare the J at the beginning. I need because I need to one more for loop. I will explain why I need one more for loop. I will explain. So my aim is I want to print the array values. So array values A of percentile D A A of I ends with semicolon. First I will try to run this program. I will save this program. This is a conversion program decimal to binary. So D2B dot C D2B.c I given. I will try to check for compilation errors, any syntax errors at the time of compilation. Yeah, there is an error I found. This one, yeah, there is no array defined with the name A. Actually, our input array is B. So I given A, that is the reason I got error. So I corrected it now. So now the errors are zeros and number of warnings also zeros. So I can start run my application to watch the output. When I'm running my number, suppose I will give you the same numbers what I projected on the screen. Suppose if I given 29, I should get 11101. If I given 78, I should get 1000110. So first I will test for 78. If I given my input number as 78, what I am trying to get? Just you check it. Yeah, there is an infinite loop happened in my program. Just I will check this one. J is less than or equals to 0. Because when we try to start our journey from the maximum value, we need to end up with the minimum value. If that is not happen, what happen every time this condition is never becomes false, so that it is running infinite number of times. That's why I got the output as infinite number of times. Next one. I will try to run this program. Now I will give you 78. You can find out, so nothing is printed here means there is a logical error in my program. Just we need to go back to program and we will try to print that one. So here B of I is holds the this input and J is see here I am taking the loop control variable as J, but I am printed here as I. That is the reason it is not generated any output while I am checking the program. Now again, once we made any changes, save the application, compile and run. Now I will. So this time, right. So after this, we started our journey from I minus 1, j is less than or equals to 0. So this is j minus minus, because when we started our journey from the maximum value to minimum, then we need to perform decrement operation. See, when we started our journey from the least value or minimum value to the maximum value, then we need to start performing the increment operation. Again, once we made any changes, save it, compile and run the program. See, so 1000110, 100. See, in this screen also we got the same thing. Just I am trying to highlight 100 triple 110. 100 is the output. The same output while we manually done the operation like conversion. The same series of numbers are generated. 100 the same output we got. 100 we will give you this input. Suppose 28, so 29. If you given 29, we are expecting 11101. Input value is 29. So I will give you the same number, 29. So 1110. So whatever I projected on the screen, triple one zero. This one from bottom to top. From bottom to top. Triple one zero one. See, I did not explain about the second for loop. Why I taken one more for loop means I want to print my array. My array inputs are, see, initially I declared an array, but I have not initialized any values. I initialize the values inside the loop. So my array feeded with some values. But those values are, if you observe here the screen, if you observe the screen, first we are holding this last digit. Last digit in our output is assigned for the zero index. You got my point? And second last digit, the second remainder is stored in first index. Next third remainder is stored in second index. Fourth remainder is stored in third index because arrays are started, index values are started from zero. So the binary array B at zero index it holds one index zero, and 2 index 1, 3 index 1, 4 index 1. But we need to generate the output in the reverse order. Actually, the binary array holds the values like from least significant bit to most significant bit. But actually, we need to drop the output from bottom to top. That means we need to print the last element first, second last next, third last next, fourth last next, up to the zero index. That means we need to start our journey from the last index. So what is the last index value? That is I minus 1. That is I minus 1 is the last index value. So last element, the last remainder value I want to print first. So next, I minus 1 decremented by 1. Decremented by 1 means I minus 1 becomes I minus 2. I minus 2, I minus 3, I minus 4, I minus 5 and so on up to some time. After some time it generates 0. If it is less than 0, it stops the process. If it is greater than or equals to 0, it will continue. Then we are printing the by target array. So by using printf percentage b of j, which prints all the elements in the given array. So very simple thing. Straight away, I try to find out the remainder. So remainder with what number? 2. Why? Because our target is binary. So we try to find out the remainder values of when we try to divide with 2. So that input number is n modulus 2. Where we need to hold the remainder values in an array. Why? Because multiple remainders we need to hold it. So that is the reason we declared an array. So these values are assigned to that array. And after that, each time the divisor value should becomes the half of the input number, half of the previous divisor, that can be conveyed by using n division 2. At last n value becomes 0. Whenever n value becomes 0, we have to stop the process. That means up to n greater than 0 only it will run. So whenever n value becomes less than 0 or equals to 0, then you stop the process. So that's the reason we given the condition as n greater than 0. After that, our binary array holds the remainders in actual order, that is, but we need to print them in the reverse order. So if you want to print them in the reverse order means last index value should be printed first and first index value should be printed last. That is the reason we given a logic like this. J is equals to I minus 1, j greater than 0, j minus minus. Finally, we print the output. Like this, we can convert the given decimal number to binary.